Hello, dear electrical students. Welcome to Electrical Power System lecture series. Today, we will learn about the power flow through transmission line. I am Professor Manan Desai from Department of Electrical Engineering, Dr. Subhash Technical Campus, Junagadh. The learning outcome from this lecture is introduction of real and reactive powers, power flow through transmission line, single line diagram of three-phase transmission, its derivation, and circuit diagram methods. Now, move towards the introduction. The electrical power generated in the generating station is transmitted using transmission lines. The distance between 2 points and we have to deliver the power, we use a transmission lines. It is a conductors designed to carry electricity over long distance with minimum losses and distortions. The parameters associated with these transmission lines are inductance, capacitance, resistance, and conductance. These four parameters we have discussed earlier in short transmission lines, medium transmission lines, and long transmission lines. Now, we are starting from a generating stations, and here you can see the single line diagram of generating stations to load. The transmission lines connected between them. We can understand with the ABCD parameters. Here, students, you see the bus 1 and bus 2. SS is equal to PS plus JQS. Means this is apparent power at sending end is equal to PS, real power at sending end, plus JQS means reactive power in sending end. Same like in receiving end, SR plus PR plus JQR. Now, VS have some angle delta, it is load angle, and VR is a reference, so it is on zero angle. Now, from this figure, we can assume VR is the receiving end voltage. It is a reference phasor, so it is on zero angle. VS is equal to VS at the delta angle. It is a phase angle between sending end and receiving end voltage. So on the reference phasor, it is on zero angle, but while we sending the power from sending end to receiving end, VS have some angle, which is a load angle we can say, or phase angle between sending end and receiving end. Now, power flow in the transmission line have generalized constants are ABCD parameters. Now it has on some angle, like A is alpha attenuation constant, B beta has a constant, C has a propagation constant, D delta has a load angle constant. So this complex power at receiving end with the parameters of SR is equal to PR plus JQR. This is our equation 1. Here IR is a conjugate of receiving end current IR. And we know that Vs is equal to AVR plus BIR. So from the above equation, further we simplify IR is equal to Vs minus AVR upon B. Vs have some angle delta minus A have on angle alpha. VR, as we say, it is a reference phasor, so it is on zero angle, and B is on beta angle. So after simplification, Vs with the B, so Vs upon B, angle beta will upstairs delta minus beta minus AVR upon beta, it is a 0, so alpha minus beta. This is our equation 2. So if IR conjugate, we can say Vs upon B, we can shift the position of beta and delta, beta minus delta minus AVR upon beta, beta minus alpha. We can shift the position, earlier position, and now beta minus delta. Earlier it is delta minus beta. You can see here. Now we put the value IR in equation 1, and then we get SR is equal to VR IR, and this is our IR equation. VR, it is multiplied with IR equation. So Vs VR upon B, beta minus delta, minus A VR square upon B, beta minus alpha. This is our equation 3. Now we separate the real part and imaginary part, so we can derive the P and Q. So P at receiving end is Vs VR upon B cos beta minus delta minus AVR square upon B cos beta minus delta. This is our actual power, or it is in receiving end. Now reactive power is like sine Vs VR upon B sine beta minus delta, AVR square upon B sine beta minus delta. So alpha and beta we have to separate for P and R. This is our equation 4 and 5. For fixed values of Vs and VR, power received will be the maximum when cos beta minus 1, when delta is equal to beta. So see, in earlier equation, this all Vs and VR and all these parameters are fixed. So for the maximum power, we have to calculate the variable component, and the variable component is this. After all, cos beta minus delta, if cos beta minus delta is 1 and delta is equal to beta, then we achieved maximum power at the receiving end. So Vs VR upon B minus AVR square upon B cos beta minus alpha. In previous slide, see, this cos beta minus alpha have to be 1. If this will be 1, then Vs VR upon B into 1 minus AVR square upon B cos beta minus alpha. This equation is our maximum power equation. See this. And reactive power maximum is AVR square upon B sine beta minus alpha. So if cos beta minus delta is equal to 1 and delta is equal to B, we can calculate the PR max and QR max. This is our equation 7 and 8. In transmission line, A is equal to D is equal to 1. So we can put the value 1 at the angle 0 in above equation. Also, B is equal to impedance. So we can put the Z in place of B at the angle theta. Now, further simplified the equation 4 and 5, we got PR is equal to VS VR upon Z. See, we put the value Z in the place of B and we remove A because it is 1. So VR upon Z square cos theta. QR is equal to VS VR upon Z sin theta minus delta minus VR sin theta, because alpha is equal to 0 and beta is equal to 0. Now in the transmission lines, the we can compare between resistance and reactance. Reactance has a very much high amount compared to resistance. Means resistance is too small with compared to reactance. So we put the maximum or heavy component reactance in place of Z, because Z is made from R plus JX. While R is very small, we can put the X in the place of X. And theta is equal to 90. So for PR is equal to VS upon VR by Z sine delta, because we put theta is equal to 90. And QR is VS upon VR upon X minus VR square upon X. Because delta is a power angle and it is usually very small, so cos delta is equal to 1. So we removed these terms and simplified PR and QR. Now, method of finding the performance of the transmission line, we have basically two methods. Which one? First is analytical method and second is graphical method. Analytical method is found to be laborious, while graphical method is convenient. So graphical method or circle diagram are helpful for determination of active power and reactive power and power angle and power factor for given load conditions. Relations between the sending end and receiving end voltage and currents are given below. ABCD parameters are generalized constant of transmission, and hence Vs is equal to AVR plus BIR and Is is equal to CVR plus DIR, where Vs is a sending end voltage, VR is a receiving end voltage, Is is sending end current, and IR is receiving end current. By taking either these four components as a reference, these characteristics can be plotted. These characteristics are nothing but representing circles. Hence, such diagrams are called circle diagrams. Circle diagrams is drawn by taking active power P on x-axis and reactive power Y on imaginary axis or y-axis. So now receiving end power circle diagrams. It is true power on horizontal axis and reactive power on vertical coordinates. From the equation, Vs is equal to AVR plus BIR, IR is equal to Vs minus AVR by B, and it has some angle. Now we simplify delta minus beta and alpha minus beta, and further in conjugate form we shift the beta position, so beta minus delta and beta minus alpha. Now volt ampere means VA at the receiving end, it will be SR is equal to PR plus JQR. So it is VR IR. VA means volt ampere received at a load center. So VSVR upon B, beta minus delta, and AVR square upon B, beta minus alpha. These equations are simplified by this way: cos beta minus delta plus J sin beta minus delta, and cos beta minus alpha plus J sin beta minus alpha. Now SR is equal to this equation. As you see here. Now, by separating real and imaginary parts, we have PR and QR. The power component can be expressed as a PR plus AVR square B cos beta minus alpha is equal to VS VRB cos beta minus delta. We have shift this component in the addition of PR. So PR plus this component is equal to this component. And same like this, QR we have shifted this, and VS VR upon B. Now squaring and adding these equations will give, see, we squared these equations PR and QR. It will give us the equation of circle. So now we confirmed about our coordinates are AVR square upon B cos beta minus alpha, AVR square upon B sin beta minus alpha, and VS VRB are our x coordinate, y coordinate, and radius of circle respectively. As you see, after squaring AVR by B cos beta minus alpha, this component is our x coordinate. AVRB by sin beta minus alpha, this component is our y coordinate. And VSVR by this component is our radius of circle. Now construction of circle diagram. Plot the point, a center of the circle N on a suitable scale. From N, draw an arc of a circle with radius VSVR by B. From the origin O, draw the load line OP inclined at angle phi r with the horizontal. Let it cut at circle P. Then receiving end power and reactive power will be represented by OP and PQ respectively. If the voltage is Vs and Vr are taken phase voltage in volts, then power indicated on x-axis and y-axis will be watts and VAR per phase respectively. this, if the voltage Vs and Vr are taken line voltage in volts, then the power indicated as watts and VAR for all three phases. Vs and Vr taken from line to line, then in kV and in kV, then power is indicated will be megawatt, and MVAR means megavolt ampere reactive. And to determine the maximum power at the horizontal line is drawn from the center of the circle intersecting vertical axis at the point L and the circle at the point M. Distance Lm represents maximum power for the receiving end. Now, this is a circle diagram where N plotted a circle. This is a circle where the radius is Vs upon Vr. The origin O intersects the point P, which represents the power as R is equal to PR plus JQR, and PQ is a reactive power. This is an active power, OQ. This power is on Y coordinate. Now, from N, this is the two coordinates on X coordinate and its Y coordinate. Cos component is on X coordinate, Y component is on Y coordinate. Okay, this is our generalized circle diagram. And now, what is this? This is a receiving end power circle diagram. We received the actual power and reactive power. So in this, we fixed our X coordinate and Y coordinate, and same like in sending end power circle diagram, D upon B Vs square. See, the radius are same, Vs Vr upon B. This is a radius, this is a N, and we draw the circle. This is a circle where the radius Vs upon Vr, the origin O, this is a sending end power, this Qs is a reactive power from the sending end, and we calculate it on the scale of megawatt on x-axis and MVAR on y-axis. So students, this is our sending end power circle diagram, and I hope you all clear about ABCD parameters and power flow in the transmission lines, where the receiving end power circle diagram and sending end power circle diagram. So we took a fast conclusion that we have seen receiving end true power PR and receiving and reactive power QR. You can see the equation. Maximum power PR and QR, construction of circle diagram, and receiving end and sending end power circle diagram. Okay, thank you very much. Thank you all of you.